In Monet, we can use all of the mathematical comparison operators. So here I have an example. So we can use less than operator, greater than, less than or equal, equal, and so on. I will run this statement, and this would be the result. Now we can use these operators with numbers, but we can also use them with strings. So here is an example for strings, and we can see that we can use all of the operators both for numbers and for strings, and we are comparing whether, for example, this string is smaller than this other string, and the string that is closer to the start of alphabet will be smaller. So this should be smaller. So if I run this, I will get the result true. Now, beside operators, we also have functions, and those functions are just a counterpart of all of these operators. For example, counterpart of this operator is this function, so it is obvious what each of these functions do. This is just a different syntax to achieve the same thing. I will run this, and we can notice that we would get the same results as above. I will now clean my screen. Next, we will talk about functions and operators that work with nulls. We will start with is null operator, and this operator is useful when we want to test whether something is null. So this is obviously null, so when we run this, we would get true, but for a number, we would get that this number is not a null. We also have the opposite version of this operator, and that would be is not null, so that would give us the same result, just the opposite. Next, we can see how coalesce function works. This function can accept any number of arguments, but it will return the first argument that is not null. So in this case, this is the first argument that is not null, and that argument will be our result. And only if all of the arguments are nulls, then coalesce function will return a null. So if I run this, this would be our result. Next, we can take a look at if null function. This function is special because it has these curly braces, and it also has these two letters fn. If null is actually working the same as coalesce function with two arguments. So while coalesce function can have many arguments, if null can only have two arguments, and the result would be calculated in the same way. So in this case, this is the first argument that is not null. This would be the result for this second expression, and only for this third expression we would get a null as a result. And we can see that here. Next, we can talk about null if function. This function accepts two arguments, and if those arguments are the same, then the result is null. But if they are different, then the result will be the first argument. So let's run this, and we can see that in this case the result is null, but in this second case, because arguments are different, the result will be the first argument. Next, we can take a look at is null function. This is null function is also used to test whether something is null. So in this case, we obviously have a null, so the result would be true, and in this case we would get false because this is a number and not a null. I will now clear my screen. Between operator is useful when we want to test whether some value belongs to some range. So whether number 2 is between 1 and 3. And if I run this, we will see that that is true. We can also use the opposite version of this operator, not between, so in that case we would get the result false. This operator is working not only with numbers, but it will also work with strings. So instead of using 1, 2, and 3, I will use strings A, B, and C on the same position, so we would get the same result, and we can see that it is working correct. This between operator is inclusive. So that means that if our range is between 1 and 2, then boundaries 1 and 2 are part of this range. So is 1 between 1 and 2? Well, the result would be true. So if I run this, we would get the result true. And this is because mathematical description of this operator is like this. We want to see whether 1 is greater or equal to 1 and whether 1 is smaller or equal to 2. In this second expression here, we are testing whether BB is between AA and CC. But we have to respect proper order. Lower boundary has to be wrote first, and then we have to write a bigger boundary. And only in that case we would get the result true, but this time we got false. So how to solve this problem? Well, we have to properly sort our boundaries, but what to do with we do not know in advance what boundary is smaller and what boundary is bigger. Well, in that case, we can enhance our between operator with symmetric keyword. This symmetric keyword will first sort our boundaries. So it will change the order in this case because the order is not proper, and only then will apply between operator. We also can use not between symmetric to get the opposite result. So in this case, this first expression will return true. Although the same expression without symmetric keyword was returning false, but now we would get true because our boundaries are properly sorted. I will now clear my screen. Beside between operator, we also have a between function. This function has 8 arguments. I will explain all of them except this one. I really don't know for what is this argument used, so I will explain only other arguments. And we will see that this function is more powerful than between operator because it has all of these controlling arguments. These arguments are used to control behavior of between function. This time we will use false for all of these arguments. So this function will check whether this value is inside of this range. But contrary to between operator, between function is not inclusive. So in this case, there is only number 2 in our range. 1 and 3 are not included, so this example will return false. Now we can change this not inclusive behavior to be inclusive by using this last argument. So if we change this last argument from false to true, now our range is fully inclusive. So now our range is 1, 2, and 3. So if we check whether 1 belongs to this range, we would get the result true. We can also make our function partially inclusive. In this example here, we are changing this argument to true. Now only lower boundary is inclusive. So now our range is 1 and 2, not including 3, because only lower boundary is inclusive. And in this case, again, we would get the result true. We can do the opposite. We can make only the upper boundary inclusive. In that case, we would change this argument to true. So now only upper boundary is inclusive. So this will return again true. We can also use this fourth argument. When we use fourth argument, we will change the behavior of a function if this first argument is null. So in this first expression, all of these controlling arguments are false. So we will see default behavior of between function. So I will run this, and default behavior when first argument is null is to return null. But if we change this fourth argument to true, in this case, instead of getting null, we would get false. So this is the usage of this fourth argument. I will now clear my screen. Like function is used to compare a string with a pattern. Inside of a pattern, we can use wildcards, and wildcards can be a percent sign which will represent 0 or many characters, or we can use underscore which will represent 1 character. If we run this, we will get the result true for both expressions because this string is according to these patterns. Now, if our string has inside of it a percent sign or underscore, like in this case, then we would have to mention that sign inside of a pattern. But everything inside of a pattern that is percent sign or underscore will be considered as a wildcard, and we want to prevent that. For this purpose, we will provide this third argument, which is an escape sign. If we place an escape sign before percent sign in this second argument, then this percent sign will not be recognized as a wildcard, but just like ordinary sign. So this pattern here will fit to this string. If we run this, we will get the result true. Now, if our string is, for example, lowercase and pattern is uppercase, then we can still get a match. And for that, we have to change this fourth argument to true. Now comparison is case insensitive, so we would get the result true. There is also an opposite function from this like function, and that would be not like function, which will just reverse the results from before. Next function we will talk about is if then else function. This function will give us ability to conduct ternary logic. In first argument, we should calculate some expression which will return true or false. And if this expression returns true, then we will return this second argument as a result of this if then else function. And if this first argument returns false, then it will return this third argument as a result of this function. In this case, our first argument is true, so this will be the result of this function.